The beauty of summation notation is that it works for any sort of patterned data. So if there's a formula you can use to figure out what the next term in the series should be, summation notation is very helpful for that. However, there are two very special patterns that make it super easy to calculate the value of a series: arithmetic patterns and geometric patterns. We're going to start off by looking at arithmetic patterns. So do this for me. Quick pause. I want you to continue the patterns in these two different sequences and then describe what those patterns are. So pause it, unpause when you are ready to check. Here's what I hope. So in looking at this, from 4 to 7, 7 to 10, 10 to 13, we're just adding 3 every time, yeah? So the next terms should be 16, 19, 22, 25, and then that can continue on and on. What's the pattern? We add 3 every time. Down here, 18 to 11, 4 to negative 3, we're just subtracting 7 every time. So the next one would be negative 10, negative 17, negative 24, and you can continue that on as much as you want. Here we are just subtracting 7 every time. Important to know, subtracting 7 is the same as adding negative 7 each time. So really, both of these patterns are the same. To get from one term to the next, you are simply adding the same number every time. That particular pattern is called an arithmetic pattern. And so if you have a list of numbers found that way, you have an arithmetic sequence. A sequence is just a list of numbers. An arithmetic series would be where you take those numbers and put plus signs in between them and add them all up. So, what is an arithmetic sequence? It is this. From term to term, you have a common difference. That common difference is the number that you add on each time. So in our examples, it was the 3 and the negative 7. We denote that with a D for difference. And you should have seen this back in IM1 at some point. There are two different formulas. They're essentially the same thing. This one is based on the first term, and you add on n-1 common differences. So over here, I've got a sequence described that way. So the first term of this sequence is 13. And then from term to term, you're subtracting 2 each time. So the common difference is 2. First term, common difference. See how that works? So to get from the first term to the second, well, you just subtract 2. The beauty of this formula is that if you want to find any particular term in the sequence, like the 4th term, for example, you can just put a 4 in for the n and see what happens. So let's do that real quick. 4 minus 1, that's 3. 2 times 3 is 6. 13 minus 6 is 7. And sure enough, 2, 3, 4, the 4th term in the sequence is 7. So with the formula, you can get to the 4th or the 10th or the 10,000th term just by putting that term number in for the n. The second form you might see of an arithmetic sequence, again, is essentially the same thing, except you start with what is called the 0th term. This is what the term would be if the pattern continued backward before the first term. Why would you do that, you say? There are times when it's helpful. When you're looking at a graph, for example, the interpretation of the 0th term is the y-intercept of a line. Notice the formula looks a little simpler as well because it doesn't have that extra -1 in there. And it gives you the same results. So here's an example of this same sequence just described in this second format. So 15 minus 2n. For the first term, put a 1 in for the n. 2 times 1 is 2. 15 minus 2 is 13. So you get the same thing. You can get any other term in the sequence the same way. So which of these is better? Depends what you're doing. I just want you to know they're both okay. If you're interested in how you go from this one to this one, there are a few ways. I'm sure you can figure them out. Now on to our focus. So we've talked about an arithmetic sequence. It's just a pattern of numbers where you're adding the same number each time. The formulas tend to look like one of these. Well, wouldn't it be fun to add them all up? I think it would be. Then it becomes an arithmetic series. So this is where you take an arithmetic sequence and put plus signs in between the numbers. It turns out, because of the structure of an arithmetic series, there's a shortcut that can help you find the sum of a series without actually having to add up each individual term. I'm going to leave that covered for now. It'll show up here in the next part of the lesson.